There is a galaxy in the early universe that has gone still. Almost 12 billion light-years from Earth, in a region of space that should still be tearing itself apart, something has stopped. Not slowed, stopped. And the James Webb Space Telescope, sitting nearly 1 million miles from our planet, has been staring at it for the better part of 2 years, trying to make the data fit any model of physics we currently trust. None of them work. That galaxy should not exist. Not in that condition, not in that era, not anywhere near that age of the universe. The astronomers who found it have published, retracted assumptions, run new simulations, and started over. They keep arriving at the same conclusion. The galaxy is real, the data is real, and what it's doing breaks the rules. This is the story of how we found it, and why the silence at its center is now the loudest problem in cosmology. Before we're done, you'll hear one specific number that, when it came back from JWST's spectrograph, made a room full of senior astronomers go quiet. I'm holding it for later because the number only makes sense once you understand what it was supposed to be. To grasp why this discovery matters, you have to picture what the early universe is supposed to look like. Roughly 13.8 billion years ago, the universe began as a hot, dense soup of energy and basic particles. For the first few 100 million years, there were no galaxies at all. There weren't even stars, just hydrogen and helium gas drifting through total darkness. Then gravity started winning. Pockets of gas began to clump. Clumps became clouds. Clouds collapsed into the first stars, which burned bright and short and exploded violently, seeding the universe with the heavier elements that everything else, including you, is made of. By about 1 billion years after the Big Bang, the universe was a kindergarten on fire. Galaxies were small, lumpy, and gas-rich. They were forming stars at insane rates. Some were spitting out the equivalent of 1,000 new suns every year, which is about 1,000 times faster than the Milky Way produces stars today. These were violent objects, hot, bright, restless. They were not supposed to be settled. They were not supposed to be old. And they absolutely were not supposed to have stopped spinning. A galaxy is, in some sense, defined by its rotation. The Milky Way spins. Andromeda spins. Every spiral galaxy you've ever seen in a textbook spins. Even elliptical galaxies, the older football-shaped ones, have stars whipping around in chaotic orbits. All of it driven by gravity organizing matter into something that resembles motion. When a galaxy forms, the gas falls inward and the rotation tightens up, the way an ice skater pulls in her arms during a spin. Faster, smaller, more coherent. By the time the galaxy is mature, it has a defined disk, a center, and a rotational structure that will outlive most of the stars inside it. That's how it's supposed to work. That's what every simulation predicts. That's what every observation, until recently, supported. Now meet the telescope that broke the model. James Webb launched on Christmas morning of 2021, traveled almost 1 million miles to a parking spot in space called L2, and unfolded a gold-coated mirror over 21 feet across. To get a feel for that size, picture a residential 2-car garage door. Now picture the entire thing as one polished, segmented mirror, kept just a few dozen degrees above absolute zero so it can detect infrared light without its own heat blinding the sensors. JWST was built to do one thing better than any instrument in history. It was built to see the past. Because of the way light works, every photon JWST catches is old. The light from your reading lamp takes a nanosecond to reach your face. The light from the sun takes about 8 minutes to cross 93 million miles to Earth. The light from the nearest star outside our solar system takes a little over 4 years. And the light from a galaxy almost 12 billion light-years away has been traveling toward us since before the Earth was a thought, since before our Sun even ignited. When JWST sees that light, it is literally seeing what the universe looked like back then. Not a reconstruction. The actual photons that left a galaxy when the universe was a fraction of its current age. This is the instrument that found the thing nobody could explain. The data was telling them something impossible. They were looking at a galaxy that had already finished forming. In a part of the universe where, according to every working model of cosmology, nothing should have finished anything yet. That alone would have been enough to write a paper about. But the longer the team observed it, a second problem emerged, and it was the worst of the two. The galaxy wasn't just dead, it wasn't moving. Its rotational velocity, the number that measures how fast the galaxy's matter is orbiting its own center, was anomalously low. Galaxies that massive, that compact, should be spinning at hundreds of miles per second. This one was barely rotating at all. Something had drained its angular momentum, the equivalent of an ice skater coming out of a spin and then refusing to ever spin again, for 1 billion years. When the paper landed in the journal Nature, the response from other groups was not skepticism, it was alarm. Within weeks, independent teams using their own JWST observation time reanalyzed the data and ran the spectrum through different pipelines. They got the same answer. A group at the University of Edinburgh, led by Adam Carnell, had been investigating a similar set of distant red galaxies and confirmed the basic finding. The dating method, called spectral energy distribution fitting, is not magic, but it is well understood. It compares the wavelengths of light coming off a galaxy to libraries of stellar models, and it tells you, with measurable error bars, what kinds of stars are inside and roughly how long they've been burning. The error bars on this galaxy were large. They weren't large enough to make the answer wrong. Other teams started checking the rotation independently. The technique uses something called the Doppler effect, the same physics that makes a passing ambulance siren shift in pitch. Light coming from a galaxy's spinning side gets slightly bluer or redder, depending on whether that side is moving toward or away from us. By measuring those shifts across the galaxy's face, you can map its rotation. When the maps came back, they all said the same thing. The blue and red shifts were tiny. The motion was tiny. The galaxy was, by any reasonable definition, sitting still. This is the piece that keeps cosmologists awake. The object JWST found contains the mass of roughly 100 billion suns. Our own Milky Way, including its full dark matter halo, weighs in at around 1 trillion solar masses. But its stellar mass alone is somewhere between 60 and 100 billion suns. So this thing out there, in the deep past, is comparable in stellar mass to a fully grown modern spiral galaxy. The kind it took our part of the universe nearly 13 billion years to assemble. And it managed to grow that big, then turn off, then stop spinning in less than 2 billion years. Picture a redwood tree growing from a seed to its full 1,000-year stature in a single afternoon. Then picture the tree dying that same afternoon, completely silent, never producing another leaf. That is the order of impossibility we are dealing with. Or pick a different frame. Picture every house in every American suburb being built, lived in, abandoned, and falling to ruin between breakfast and dinner. That is the kind of timeline this galaxy is asking us to swallow. If you could somehow float in deep space within sight of this galaxy, you would see something that doesn't match anything else in its neighborhood. The galaxies around it are blazing, bright knots of light scattered across the dark. each one a furnace of new stars, throwing out energy at rates so high that an unprotected human eye would be blinded in seconds. This one is dimmer, reddened, older looking, the way an old photograph looks compared to a fresh one. There is no glow of star formation. There is no spiral structure. There is instead a smooth, almost amorphous mass of ancient stars, sitting in space with a serenity it has no business possessing. This is where the question shifts from "what is it?" to "how did it happen?" And every theory we have about galaxy formation, including the ones we're about to walk through, has run into the same wall. First theory: maybe it merged. In the early universe, galaxies routinely smashed into each other and combined. Two medium galaxies become one big one. Sometimes those mergers shut down star formation by burning through all the available gas in a single violent burst. This theory has the advantage of explaining the size. It has the disadvantage of failing to explain the timing. To produce a galaxy this large through mergers, you need a long chain of smaller galaxies forming, colliding, and stabilizing. That chain takes more time than the universe had at the moment JWST was looking at. Less than 1 billion years is not enough. Second theory: a supermassive black hole shut it off. Almost every large galaxy we've ever studied has a supermassive black hole at its center, and when those black holes are actively feeding, they pour out radiation so intense that they can heat and expel the surrounding gas. No gas means no new stars. This kind of process is called active galactic nucleus feedback, and it's been observed in older galaxies for decades. The problem is the scale and the speed. To shut down star formation in a galaxy this big, this fast, you need a black hole already millions of times the mass of our Sun, already mature, already feeding violently, in an era when even basic black holes weren't supposed to be that big yet. The theory works mechanically. The clock disagrees. Third theory: dark matter. The invisible scaffolding of the universe, the stuff that makes up about 85% of all matter, might have behaved differently in this specific region. Maybe it clumped earlier than expected. Maybe it concentrated faster. Maybe the standard model of dark matter, which has worked beautifully for decades, has hidden assumptions that break in extreme early universe conditions. This theory is mathematically interesting, but observationally unprovable. We can't see dark matter. We can only infer what it's doing from what it pulls on. And what it's pulling on in this galaxy doesn't make sense. Fourth theory, and this is the one keeping cosmologists genuinely worried: the universe is older than we think. Or, equivalently, it grew up faster than physics says it should have. The dating of the Big Bang and the timeline of the universe's evolution rest on extraordinarily precise measurements, including the cosmic microwave background, the leftover radiation from the universe's first light. Those measurements give us 13.8 billion years, give or take a few hundred million. If JWST keeps finding galaxies this mature, this fast, then either we've been miscounting time, or some piece of the growth equation, the rate at which structure forms from raw gas, is fundamentally off. Both options are bad. Both options require us to rewrite parts of the standard model of cosmology. Adam Rees, who shared a Nobel Prize for his work on the expansion of the universe, has called these JWST discoveries uncomfortable. That word is doing a lot of work in that quote. When a Nobel laureate uses understated language to describe an observation, it usually means the observation is worse than he wants to say out loud. And the galaxy that stopped spinning is the most uncomfortable of all. Here is the number I told you I was holding. The team measured the galaxy's stellar age, the average age of the stars inside it, at roughly 1.5 billion years. By itself, that sounds reasonable. Now consider this. The light JWST caught from the galaxy left it when the universe was about 2 billion years old, which means 3/4 of the universe's existence up to that point had been spent inside this single galaxy. Almost every star inside it had to have formed in the first 500 million years of the universe being a universe. That is the era when, by every previous model, only the first generation of stars was supposed to exist. Primitive objects burning through their fuel in a few million years and exploding. There was not supposed to be enough time for 100 billion solar mass galaxy to assemble itself from those ashes and then shut down, all in the first 500 million years after the Big Bang. The team rechecked their work. They reran the models. They calibrated against other JWST observations. The number didn't move. That number is the headline. Everything else is consequence. If you could stand on a hypothetical planet around any star in this galaxy, you would look up at a sky that doesn't move much. The stars overhead would be ancient. Most of them would be red. None of them would be young. There would be no nurseries of newborn suns, no bright nebulae, no shooting stars from infalling debris. The violence that defines our part of the universe, the constant churn of new stars being born and old ones dying, would be absent. It would feel like standing in a cathedral after closing time, silent, preserved, beautiful in the way a corpse can be beautiful. The temperature of intergalactic space around it is about -454 degrees Fahrenheit, just a few degrees above absolute zero, the coldest temperature physically possible. The galaxy itself is barely warmer. There's almost no gas to be heated by anything. The fuel that would normally power new star formation has either been blown out, locked up in long-dead stars, or simply isn't there in the quantities needed. Whatever processes normally drive a galaxy forward have ground to a halt. There's another implication worth pausing on. New star formation isn't just decoration. It's the engine that produces the heavier elements life depends on. Carbon, oxygen, iron, all the way up the periodic table to gold and uranium. Those elements are forged in the cores of massive stars and scattered across the cosmos when those stars explode. A galaxy that stopped forming new stars at the moment we're observing it is a galaxy where the chemistry of the universe has frozen in place. Whatever heavy elements existed there at the moment of quenching are all that will ever exist there. Any life that somehow began before the silence would be working with a finite, fixed inventory of building blocks, drifting through a sky of red, dying suns, with no fresh supernovas to replenish the supply. It is the closest thing astronomy has yet imaged to a graveyard the size of a galaxy. And here is where the story widens. This galaxy isn't alone. Over the past 2 years, multiple teams using JWST have identified what astronomers are calling red, dead, and ancient galaxies in the early universe. They aren't all stopped the same way. Some still have a faint trickle of star formation. Some show traces of recent mergers, but the population is growing. And the more JWST stares into deep space, the more of them turn up. Some appear at the same distance as Glazebrook's galaxy. Some appear even farther. A few are at distances where, according to the standard model, no large mature galaxy should exist yet at all. We are no longer looking at a one-off anomaly. We are looking at a class of objects that, according to the rules we've been working with for decades, has no business being there. And among them, there is at least one that seems to have stopped doing the most basic thing a galaxy does, which is move. Some cosmologists have started using a careful word: tension. As in, there is tension between the JWST observations and the standard model. The word is diplomatic. What it really means is that something, somewhere, in our understanding of the early universe is wrong, and we don't yet know which thing it is. The next round of observations will start narrowing it down. JWST will continue surveying. The Nancy Grace Roman Space Telescope, scheduled to launch in 2027, will image vast patches of sky in deep infrared and find more of these objects, if they're out there in the numbers some theorists now suspect. The Vera C. Rubin Observatory, sitting on a mountain in Chile, will provide a complementary view from the ground, scanning the entire visible sky every few nights. Together, they will tell us whether the galaxy that stopped spinning is a freak occurrence, or the first clear hint of something we've been missing about the universe's first billion years. If it turns out to be common, the consequences are enormous. Models of dark matter, of black hole growth, of how the universe kept time, of galaxy formation, of the fundamental sequence of events that produced everything we can see, will all need to be reconsidered. Textbooks will be rewritten. Careers will pivot. Some current physics will end up being called classical, in the same way Newtonian gravity is now called classical. Accurate enough for everyday use, but wrong at the extremes. If it turns out to be rare, we still owe an explanation. Why this galaxy? Why now? Why this place in the early universe? What kind of process can take 100 billion solar masses of gas and stars and freeze them in place before the universe has even reached its terrible twos? There is no good answer yet. The team that found it is still working on it. The papers are still being argued over. Other groups are observing the same patch of sky, looking for confirmation, looking for context, looking for anything that might explain what they're seeing. Years of human effort and billions of dollars of telescope time are now pointed at a faint red smudge in the deep sky, trying to understand why it stopped. And honestly, this is the part of the story that gets to me. Because we built JWST specifically to test our theories of how the universe began. We spent decades arguing about how to design it. We spent $10 billion constructing it. We launched it nearly 1 million miles into space on the most expensive science mission in human history, knowing full well that any tiny failure during deployment would have ended everything. And it survived. And it works. And now it is patiently, calmly, methodically showing us that the picture we painted of the early universe, the picture we were so proud of, the picture we put in every textbook, has a hole in it. Maybe that hole is small. Maybe a few tweaks to the parameters will close it. Maybe the galaxy that stopped spinning has an explanation hiding in some corner of the equations we haven't searched yet. But maybe the hole is bigger than that. Maybe what JWST is telling us is that the universe in its first billion years was doing something we did not predict and cannot yet explain. Forming galaxies faster than physics allows, building stars before there should have been time to build them, letting matter settle into silence before it had any business settling. Somewhere almost 12 billion light-years away, a galaxy that should be alive with cosmic fire is sitting in perfect silence. Its stars are too old. Its disk is too still. Its existence is a quiet contradiction sitting in the deepest part of the sky. And every time a human being looks at the data, the universe tells us we still don't understand the beginning of our own story. The most unsettling thing about modern cosmology isn't that the universe is enormous or violent or indifferent. It's that we built our most precise instrument ever, pointed it into the past, and the past gave us an answer we cannot read. The galaxy that stopped spinning is not just an object out there in the dark. It is a question carved into the edge of our knowledge, waiting for someone, sometime, to figure out what it means. And until then, it just sits there, silent, ancient, refusing to move. A small, red ghost at the dawn of everything. Thanks for watching, and I'll see you in the next one.